notes from yesterday. This is the Unit 11 notes, day 2, graphing logarithmic functions. And we got down through example 2, okay, that last graphing one. So now we're on the last page here with example 3. Okay, in this set of examples, they want us to, all right, so we're going to describe the transformation from f of x to g of x. Okay, so f of x is the starting function. Here's the transformed function. So we're going to describe that transformation, and then we're going to state the domain and range and any effect or change to the asymptote, okay, from those transformations. So my strategy here, okay, we did this, I've done this for the previous types of functions as well, is to identify your A, H, and K. Okay, that is what tells us our transformations. Okay, so here, okay, the 5 is our A. And what does an A of 5 do to the graph? How would you describe the transformation that takes place due to that 5? Remember, when you have a coefficient, that A value, we can go back up here in our notes where I wrote, I think in the column over here. Okay, the A value determines the vertical stretch or compression. If A is greater than 1, it's a stretch. If it's between 0 and 1, it's a compression. So we can see, yeah, a 5 is greater than 1. So this is going to be a vertical stretch. Okay, and then let's see. The H value is what's inside there. Remember, it's x minus h, so x minus 8. So h is a positive 8. Okay, h is our horizontal shift. So a positive is to the right, since h is positive. So that is shifted right 8. Now k is what's added or subtracted on the outside, which in this problem, there is none, so k is an understood 0. So that means there is no vertical shift. Okay, it didn't go up or down any. Now, our asymptote changes with the horizontal shift. We said that your vertical asymptote is always going to be x equals h. And what is h here? 8. So x equals 8 is going to be the location of the asymptote. Now they're asking what are the changes. Where does the asymptote normally start in the original function? At 0, right? At x equals 0. So the change is it went right 8. So whatever your horizontal change is, that is your asymptote change. Now, where that asymptote is determines our domain. Okay, go back real fast and look at those original functions. It didn't matter what the base was. If it was a base 2, base 10, base E. Okay, they all have the vertical asymptote at 0, and they're all on the right side, increasing. Okay, from that asymptote up and to the right. Okay. The only thing that would change that to make our domain any different than x is greater than 0 would be if that asymptote shifted. Then obviously the domain would shift with it. Okay, the graph is on the right side of the asymptote for all of these unless it was reflected across the y-axis. Reflecting across the y-axis is the only thing that's going to switch the direction of the domain too. Otherwise, the asymptote is going to be the minimum, and then it's going to go to infinity. Okay, so think about that when we're giving the domain here. Was there a reflection over the y-axis here? There was not. So the graph is still going to be on the right side of the asymptote, and the asymptote is at 8. So what is the domain? 8 to infinity. Very good. In interval notation, that looks like this. With parentheses, you don't include the 8. Or in inequality notation, you could say x is greater than 8. Everything to the right of 8. Everything to the right of that asymptote. What about the range? Does the range for a log function change with any of the transformations? No, yesterday we said it didn't matter if there was a reflection, a stretch, a compression, a shift, up, down, left, right. The range of the log functions is always going to be all real numbers, or negative infinity to positive infinity. You can go ahead and fill that in for all of these log functions. The range doesn't change for logs. All right, in B, we're starting with a common log of x. Okay, so let's identify these different A, H, and K. So A here is negative, but no number, so that's an understood 1. So -1. What does a negative A value do to your graph? Good. Is it a reflection over the X or the Y axis? X. Okay, it is a reflection over the X axis. To be a reflection over the Y axis, that negative would have to be inside here on the X. Okay, when the A is negative, it's a reflection over the X axis. Okay, then let's see. There is a +2 on the inside. So remember up here it was X minus 8, so H was positive 8. Remember, it's the opposite. So H is actually -2. Okay, it's X minus -2 that made it +2. So the H is actually negative, which means this graph is shifting left 2. And then the K, this one has a K, is -4, which that's your vertical shift. So this graph is shifting down 4. So the only one of those that has an effect on the asymptote is H, the horizontal shift. So it was left 2. So that's the change to the asymptote. So there is a vertical asymptote at x equals -2. This was not reflected over the y-axis, so it's still on the right side of that asymptote. So what's the domain? Good. -2 to infinity. Or x is greater than -2. It's everything to the right of the asymptote. All right, let's try that with C. We're starting with a natural log. We can see we've got an A value in front of 4/9. What's that going to do to my graph? Good, it's a vertical compression. That A value is between 0 and 1. We've got a vertical compression. There's nothing in parentheses with the x. That 6 is not part of what you're taking the log of. If it's helpful to you to put the parentheses when there are none, add the parentheses. So it makes it very clear that 6 is outside. Okay, so our h value here is 0. There's nothing added or subtracted inside. So that right away tells me there are no changes to my asymptote. So my vertical asymptote is still going to be at x equals 0 because it's x equals h, right? And h is 0. And then my k value, what is added on the outside is that +6. So this is going up 6. Now, neither of those affected the asymptote. So what's the domain here? X is greater than 0 or 0 to infinity. Very good. Well, for our notes, because it asks what the change is, they're really just asking for the right 8, left 2, or no change. I'm just putting at the bottom where the asymptote is for the sake of our notes. So when you look back on this, you can see your asymptote is always at x equals h. Okay, now when you're doing an actual practice problem, it depends what they're asking. If it says, what is the change, or where is the asymptote? All right, let's try example 4. Very similar, but this time they give us the description and want us to write the equation of the transformed function. Okay, so they're saying you're starting with f of x in a, that's the natural log. Okay, but it has these transformations. We want to write the equation, give the domain and range, and any asymptote change. Okay, so first I'm going to identify a, h, and k from the descriptions. So here it tells us reflected about the x-axis. That tells me right away my a is negative. Okay, now it doesn't say anything about a stretch or a compression, does it? So a is still a 1, so it's just a -1. Then they tell us that the graph is translated 5 units to the right. Left and right is h. So to the right is positive. So h is +5. And then they tell us it's 15 units down. Up and down is k. And 15 down means -15. So I've identified a, h, and k. And so now I'm ready to write my equation. They ask us to write the new equation as g of x. Okay, so it's a natural log. The a is -1. Now I don't have to put 1. I can just put negative. Okay. Then inside the function is h. It's x minus h. And then outside the function is your k. So that's what the equation should end up looking like. Now, we already said our range for all logs is all real numbers. So we can go ahead and answer that for all 3 of these again. That's not going to change. -infinity to +infinity for the range. Now, asymptote changes, we said, are based on h. Over here, h is 5. It was right 5. So your asymptote is also going to be right 5, which means the vertical asymptote is at x equals 5. This function was not translated, or excuse me, not reflected over the y-axis, so it's still on the right side of the asymptote. So what is the domain? Yeah, 5 to infinity, not including the 5. So parenthesis, or x is greater than 5. All right, for b, we're starting with a log base 2 of x, and they tell us this one is also reflected over the x-axis. So again, I know a is negative, but then it also tells us it's vertically compressed, and it tells us by a factor of 1/2. So that's telling us it's negative from the reflection, but it's also not a 1, like in example A. It is 1/2. Okay, and then they don't have anything here telling us that there's a shift left or right. So that tells us that h is just going to be 0, no horizontal shift. But then they do tell us it's translated up 1 unit. So that tells us k is +1. So I can write my equation. Okay, g of x this time will be -1/2 is my a. And then we're doing log base 2 of x, and there's no h in here. So just immediately close that parenthesis, and then k is plus 1. Again, technically those parentheses are unnecessary in this problem because there was no h, but I like to make it very clear that that plus 1 is outside. It is a vertical shift. All right, so if h is 0, there was no horizontal shift. That means there was no change to my asymptote. And so where is my asymptote? And no changes, so it's at x equals 0. So the domain is, very good, 0 to infinity, or x is greater than 0. All right, last but not least, we're starting with a common log. They tell us this one is vertically stretched by a factor of 8. It's no reflection, so a is positive 8. And then again, I don't see any information about a translation left or right. So again, h is 0. And then they tell us translated up 10. So k is a positive 10. So when I go to write my equation for g of x, I have 8 log, no base needed, it's a common log, of x plus 10. Again, same as the last one, there was no horizontal shift, so there's no change to your asymptote, which means your vertical asymptote is still at x equals 0, so your domain is still 0 to infinity. That's a parenthesis. All right, y'all take a minute to try this exit ticket underneath. Okay, they give you a description of the transformation. So we're going to write the equation for part 1, and then they want you to graph the original and the transformed function together on that grid and describe any changes to the asymptote. So I'll give you all about a minute and a half or 2 minutes to try that, and then we will check it. If you're watching this as a video, you can just pause, give it a shot, and then unpause. All right, let's take a look at what y'all got. Let me unfreeze the screen here and y'all can check it with what I did. Okay, so what I did is I started by graphing in gray log of x. Okay, that's the parent function they're giving us, the common log. So I had an asymptote at 0. That's where it starts. I had an x-intercept at 1. And then I put a second point at 10, 1, because remember, this is a base 10. And if you have a log base match what you're taking the log of, you just get 1. We talked about that yesterday. So I know there would be, if I had an x of 10, I know my output would be 1. So I had a point at 1, 0 and 10, 1. And then I graphed that gray curve along my asymptote through those 2 points. So that's the original f of x. Then they tell us it's translated left 3 units. That means h is -3, which immediately tells me my asymptote has shifted left 3. So in red is my new asymptote at -3. Writing the equation, remember it's x minus h. So x minus -3 becomes x plus 3, and that's inside the function. Make sure it's inside parentheses. Okay, so then I just took those 2 points that I had plotted on the original and I shifted each of them left 3. And then I drew my curve through those 2 points using the asymptote as the guide for this end behavior. Do y'all follow? You need to edit or fix anything on yours, you can. Y'all have your first practice assignment for Unit 11 today. It is in ALEKS. It's called Unit 11 Practice 1. Okay, it's a combination practice over Monday's notes, the day 1 notes, and these day 2 notes from yesterday and today. Okay, so you can have out both your sets of notes to help you as you go through that practice in ALEKS. It will fall to be due, today's Wednesday, so it would normally be due Friday, but remember when it's due on a Friday, I give you the weekend. So it is not due until Sunday by 11:59 p.m. Those of you who are taking the U.S. History STAR test tomorrow, we're obviously not going to do anything new. That's the majority of my students are going to be STAR testing. If you are not STAR testing, you will meet in the pack and you can just continue to work on the ALEKS practice, that whatever you don't finish in class today. Those of you who are testing, obviously to finish the ALEKS at some later time outside of class, but you have till Sunday at 11:59 to do so. Any questions right now? Okay, so y'all get started on that practice assignment. You can work with a partner or a small group. And of course, I recommend you have your notes out to help give you a reference.